Hello and welcome back to Calculus 2, section 6.6 on surface area, and I'll say of revolution, because it is not any surface area. It is the surface area for the objects that you get by revolving a function around one of the axes. We already seen the baseball bat and the light bulb and whatever else we created, the cones and cups. And we used the formulas to calculate their volumes through disk method, washer method, and shell method. Now we want to compute the surface area of those objects, because you want to know the area maybe for purposes of marketing, to give the surface area that the artists have to work with in order to create a label or something that will go to your product. Now, not each one of those is going to be, let's say, the rectangle to wrap around the cylinder. Some of them will have the design, right, which will be produced by the function. So what we have now is, if you want to think, let's say, about, we can talk about a cone, for instance. If you have this triangular, this linear line which creates this triangle in the XY, you call this 3, call this 8, and you rotate this around x-axis, you will create a cone of height 8 and radius 3. So as you rotate this, it will create this other side, and it will create the rotation over here, and you guys have this. So the question is, what is the area of the surface? Not the area of the base, no, just the surface revolution. Area of the base you can quickly get by area of the circle, right? It's 9 pi in this case. So what's the area of what's the area over here? That's what we are looking for. Now, if you take a closer look, we do have length of curve. And if I have a length of curve, I can multiply that by the rotation, and I will get, so area of the base times the rotation will give me the area of the wrapper. So area is going to be 2 pi integral a to b f of x times 1 plus f prime squared of x dx. So you have your integral for length of a curve times the function, and then remember that the function is the radius, so your 2 pi r, right, for the circumference times the length of the curve. Circumference times the length is going to give you area. So this is your formula. You see that it's a little bit different. This is for x rotation. I need to specify that. And then we also have the y rotation formula, which is 2 pi c to d f of y square root of 1 plus f prime squared of y dy. So you have that one as well. All you need to do now is just to compute the problem. And this is one where your integration by use substitution makes appearance a lot. So a lot of these problems will be solved by integrals will be solved by use sub. So be mindful of that. Problems 7 through 20 you should be able to do by hand. Problems 24 through 28 are technology if you're looking at the book. Also make sure that you are reading carefully if you're doing the online homework, because it will tell you if you have to use the technology to integrate. Let's take a look at, let's say, number 9. Your function y is equal to 8 square root of x, and your interval is 9 to 20. And you are rotating around x-axis. We need the derivative for the formula. So f prime of x is equal to 8 times 1 over 2 root x, like this. So it becomes 4 over root x. It would be in your best interest to memorize that the derivative of root x is 1 over 2 root x. That would be, I'll write it here now. So if y is equal to square root of x, y prime is 1 over 2 root x. If you memorize this right now, you are going to see this one a lot in Calc 2. So just, memorize this as a formula. You can still use your n minus 1 rule, right? Because this is x to the 1/2. But it will always simplify into this. So it's faster if you just know it. Great, we're ready. Area is equal to 2 pi. Don't forget the 2 pi. It's a revolution, right? 9 to 20. Original function, 8 root x, times the square root of 1 plus, and now you have your 4 over root x squared dx. So do some algebra, do some calculus, and you're done. 9 to 20. Oh, kick 8 outside becomes 16 pi. 8 times 2. You still have your root x. And now you have this times the square root of 1 plus 16 over x dx. And you're supposed to integrate this. Well, you have this x. You have a root x and you have the root on the other side. Now, rule that you might have forgotten in algebra is that root a times root b is the root of a times b. So you can actually multiply x into the binomial and distribute it. So 16 integral 9 to 20 of a single square root of x plus 16 dx. 1 times x is x, and in the second one x cancels x, so you just have a 16 there. We had integral like this in a previous problem where we said u equals x plus 16, du equals dx, and then we switch the limits of integration. u1 is equal to 9 plus 16, which is 25, and u2 is 20 plus 16, which is 36. Oh, I forgot pi, guys. You see that I forgot pi? No one said anything. I was testing you all. There's a pi that it's missing over here. So 16 pi, and I have integral from 25 to 36, of u to the 1/2 du. This is 16 pi u to the 3/2 divided by 3/2 computed from 25 to 36. This is 16 times 2, 32, so we have 32 over 3 pi, and in parentheses I have 36 raised to the 2/2 minus 25 raised to the 3/2, and now you compute this. So 32 pi over 3, in parentheses I have 6 cubed minus 5 cubed. So that's 36 times 6, so that's 180 and 36, 216. So that's 216 minus 125, that's 1, that's 9. So we have 32 pi over 3 times 91. And that's equal a number, I don't care. There you go, done, problem solved. If you're asking me what is this exactly, I'm just gonna cancel pi and a 3. Right? Who cares? Like 0.14, you're gonna cry in 14 cents? Go ahead. And then I'm just going to say this is 30 times 90 because I'm lazy. And it's gonna work out to be 27, right? It's gonna work out to be this. Good enough, all right? Which is why I say a number. If I need it, I'm going to approximate it to the best abilities to be as lazy as possible, right? You can take your calculator and you can get a 12 decimal precision if you, if you really need it. Nothing other than particle physics works on a 12 decimal precision, right? The cars and machines you create, nothing works on that, that precision. Like,
Here's pi equals 3. It does.
Yeah, what?
Pi equals 3.
Pi equals 3, yeah. Pi equals 3, of course. That's what I just did, right? Cancel pi with 3, just move on. 9.81, that's 10 for gravity, right? It's 10. Move along. Because you have a safety factor of 1.5, right? As engineer. So, it's beautiful, right? Like, what do you have? We can fit 3 trucks on it. Times 1.5 safety factor, 4.5. Great. You build the bridge for that, you put it down, right? So your bridge is built for 5 trucks, you advertise 3, and then, if the 4th truck is on it, still no problem. If the 5th truck is on it, still not problem. Well, with the 6 trucks, obviously, it's going to be a problem. But that's the safety factor, right? So this is an example. Let's do another one because we can, right? There is nothing else to teach here. You understand what you are looking for, surface area of the object that is obtained by revolution. This function here is your f of x, which defines the object you have. And then you have your f of x and the f of x prime to plug in a formula. And then you have your a to b limits, which is going to represent your height of the object once you are done creating it. And if you use the shell and washer and all of that stuff, you're getting the volume. If you use this lesson, you are getting the surface area of the thing. Let's see if we can find something. Let's do something that looks disgusting and maybe we can work it out. How about problem 18? It looks interesting. The function y is given as square root of 5x minus x squared. And we are on 1 to 4 around x-axis. So try to, again, you need the derivative, you need to plug everything in a function. See if you can work out your calculus 1 integration on this one. Because definitely it's calc 1. They are not calling for technology. So they're expecting you to know to integrate this problem, whatever it works out to be. Okay, let's take a look at this. I hope you started with the derivative that had the chain rule in it, right? And then went from there. So, what is the f prime? That's the first order of business. Well, we have a derivative of a square root. We know that that would be 2 times the square root in the denominator, and then its derivative in the numerator, which is 5 minus 2x. So that's our derivative. I use this formula, guys. I use this formula here, except I don't have just x under the root to have 1 in the numerator. I have a whole function, so its derivative will go instead of 1. So once you are done with the derivative, everything gets plugged in, and let's see what happens. So area is, we start with the 2 pi, integral from 1 to 4. We have our original function first. That's 5x minus x squared. And then we have 1 plus, and I need the whole thing over here squared. And then dx at the end. Clearly, we have to clear out a lot of algebra, and then we can work the problem out. So 2 pi integral 1 to 4 square root of 5x minus x squared. And then we have 1 plus. I have 5 minus 2x squared divided by 4 times 5x minus x squared dx. Now what I'm going to do is I'm going to multiply the first root into the second root, and that is going to kill this term completely. So when I combine the 2 square roots using the formula I wrote from algebra before, where is it? There it is. So I'm using this formula. I will go with a single square root now, and then 1 times 5x minus x squared is 5x minus x squared, plus now 5x minus x squared, and the one on the bottom will cancel, leaving just 5 minus 2x squared over 4 dx. So the hope is that a whole bunch of stuff is going to cancel out when I work this algebra out, and I will be able to integrate. So 2 pi integral 1 to 4 square root of 5x minus x squared. It's time for me to square this on top. That's going to be 25 over 4. You see, you are squaring the top. 4 is not getting squared, so it stays as a 4. So 5 squared. Now we have minus. We need first times the second double. So that's 20x divided by 4. And then finally the last term is plus. We have 4x squared divided by 4. And then we have dx at the end. Well, this is awesome. Look what happens. A lot of stuff will cancel here. We have 5x minus x squared plus 25 over 4 minus 5x, right? 20 divided by 4 plus x squared dx. So minus 5x and positive 5x die off, and then minus x squared and plus x squared cancel out. Square root of 25 over 4, we are integrating 5 halves. Holy nightmare, this is awesome. 2 pi integral 1 to 4. All you have is the square root of 25 over 4 dx, which is 5 halves. So this is 5 pi integral 1 to 4 dx, which is 15 pi when you, well, let's do another step. 5 pi integral of dx is just x, computed from 1 to 4, which gives you 15 pi. Good? For the moment, there it is, 15 pi. It looked absolutely, right, crazy to start, but then with a careful algebra and little tricks, and the bag of tricks, guys, is finite. When you do, 5, 6, 10 homework questions, you will hit all of those tricks and you will know them, right? The trick that we mainly used here is multiplying these two square roots together using that algebra formula where this distributes on both terms, and that usually killed our denominator. So that was a great trick. If the basic integration is not working, then U sub must work. And if the U sub is not working, then you need glasses because you didn't see the blue T, right? Because you can't integrate in that case. That's it. We are done with this lecture. You have 2 examples. You have additional examples done in a book. By the way, for those of you that are new to my class and taking my class for the first time, I don't work out examples that are given in the book because they're already done, and they can serve as extra examples for you to look at if the examples that I do in classes are not enough. There's no reason for me to redo those examples that are already available, and you know all the letters and numbers. You can just read them if you're interested, and that's why I do extra examples from the back. Also, I pick these problems at random from homework. So if you are to look up my Calculus 2 videos from last semester or the last year, chances are that all of the examples that I've done in that particular lecture are all different than these, because I don't do prescribed, lecture notes the same. I just pick random problems from homework and I do it. So if you go back, and find 10 lectures on 6.5, probably most of the homework problems are done, right? But you should be doing my MATLAB homework because it generates insane amount of problems. If you answer a question wrong twice, it will generate new numbers and a new function for you. So it keeps the concept and the idea of the problem. It changes the numbers and the function, so you don't get stuck into that mode of memorizing just one example, and then when you hit something a little bit different on the exam, you have no clue what to do. So it's very valuable. It's really valuable tool for you guys to work with. All right, well, that's it. I'll see you tomorrow.